Hello everyone. So let's talk about today's Geeks for Geeks problem of the day. So before solving the problem, you should know about what is the prime number. And if you don't know about the prime number, so do watch and understand what is the prime number. And this is problem very simple and very easy if you know the prime number. So you are given an head of the linked list and you have to replace all the values of the node to the nearest prime number. If more than one prime number exists, an equal distance, choose the smallest and return one of the modified linked list. So let's see. I'll print the 2 to 10 prime number. So I'll just print 2 to 12 prime number. So let's see. 2, 3, 5, 7, 11. Okay. So this is the prime number and this is my linked list given to the me. So 2, 6 and 10. So what I'll do, I'll find the distance of the each prime number. So 2 prime number, I'll just check 2 to 2 the distance is 0, 2 to 3 distance is 1, 2 to 5 distance is 3, 2 to 7 distance is 5 and 2 to 11 distance is 9. So the minimum distance is the 2 to 2 is 0. So answer for this 2. Now for the 6, I'll check the distance among all this node prime number which I have and I'll return the minimum of them. So it will have 5 and 7 with the distance 1. So I have two number 5 and 7 which have the distance which distance is 1 from the 6. So what I will return? I will return the minimum among all of them. So what is the minimum? The 5. So for this the answer is a 5. They mentioned in a problem statement here if more than one prime number exists at a equal distance, choose the smallest one. So I'll choose the smallest one. Okay, for the 10, I have two numbers 7 and 11 with the minimum distance. So 7 distance is 3 and 11 distance is 1. So I will print change value with the 11. So this is I have given. So what I am actually checking, I am checking, I have suppose any integer x, I am checking x plus 1 is a prime. If it is, I'll return that x plus 1. If x plus 2 is a prime, if it is, I'll return the x plus 2. But if x plus 1 is not a prime, so I'll check for the x plus 2. If x plus 2 is not a prime, I'll check for the x plus 3. And after some operation, I get any integer x plus k, which is a prime, and I'll find the distance. This is the first prime number of with this x. So value of k either be the 1, 2, 3 or any. So I'm not. So that's why I'm taking the k. Similar for the previous, it is x minus 1, x minus 2, x minus 3, and after that I get any prime integer x minus k. So can I say this is the two first prime number? So I'll pick the first prime number. They both are the first prime number of a x. So x is any integer and x plus k is a first prime number. If I add first next greater prime number than x and x minus 1 is a smaller prime number than x. So I'll check the distance of both of this, like x plus k is less than, or I'll just check x plus k minus x is less than x minus k, like x minus k minus x. Okay, if it is satisfied, then I'll return the x plus k. If this is not satisfied, I'll return the x minus k. Okay, so these both are condition. Why I'm returning in else part? Because it will check both the condition equal to and greater than equal to. So I'll returning the x minus k at that time. So let's try to code it out. The code is very simple. So you just know what is the prime number. So I'll just format my previous code and let's try to make. So I'll write the prime number code. So boolean prime. What is the prime number code? Integer n. Okay. So there is two condition I have to check. If n is equal to 1 or n is equal to 0, I'll return the false. Okay. Nice. Now what I'll do, I'll try to go from the I is equal to 2 and I'll go to the square root of n and I plus this. Okay. And I'll just check if n modulo I is equal to I'll return the false. Okay. And else it is not satisfy the condition, I'll return the true. Okay. So this is the prime number code. If you have any doubt in the this code, just comment it out. Okay. So let's check with the, let's try to update the linked list. Okay. Now while current is not equal to null, I'll go if prime is equal to current dot value. Okay, if this is condition satisfied, I do nothing. I'll just ignore this because that is the nearest prime number. The example is a 2. Let's see. Now if this not condition satisfied, I'll just change the current value. Okay, so I'll just check change value function. It will take the current value and it will return something which is really important for me. Okay, so current is equal to current next, and I'll try to return the head of the linked list. Okay, now I left with the one function which is change value. So I'll just change the value function. I'll write the change value function. It will take the integer x. What I'll change, if x is equal to, I'll return the 2. Why I'm doing this? Because this is, I know x is equal to 1, then I'll return the 2. So I'll do the x minus k is equal to x, and there is one value x plus k. This is also there. So while I'm saying is not prime, x plus k. So I'll just do x plus k. Go to the next. So I'll get an integer x plus k. If not x minus k, I'll do the x minus k. Okay. So this both are the condition. Now what I'll do, I'll find the distance. So I'll find the actual absolute distance x minus k minus x is less than absolute of x minus k minus x. So what I'll do, I'll return the x plus k for this case, else I'll return the x minus k. Okay. So this is all about the code. If you have any doubt in the code, you'll just comment it out. So let's try to compile it and try to submit it. Okay. So it passed all the test cases. So let's try to submit it and let's see it passes all the test cases or not. If it is, then okay, yes, correct. So it passed all the test cases. So what is the time completion of this code? So it will run till the big of n time. Let's see, it will run the big of n time. Then after that, I'm checking the prime number inside it. Okay, so I'll checking the prime number. So what is the prime number time complexity? It is the root n. So it will till go to the square root of n. So big of square root of n. And what is the time complexity of this value? I don't know. So I'll just take this as the big of k. Okay, because we are running at least x plus k and x minus k. So what is the overall time complexity? The overall time complexity is big of n into square root of n into a sum integer k. Okay, so let's see. This is the overall time complexity for this code. Can we optimize further? So yes, we can optimize. Instead of calculating this, we can use of sieve of. So this is the first approach. So what we have to do at the end, we have to use the prime number list. Okay. So this is first thing we just solve, and it is the time complexity big of square root of n into k. Okay. So you can just calculate this as like n into root n, and I'm say the k is a constant. Suppose, because we know the k is not more than 2 into x. Why? Just there is no prime number. Like we get a prime number so quickly. So that's why I'm just saying the k is not a bigger value for. So we can just take the n into root n as a dominant time complexity. But still you can take a k as well. So the overall time complexity and space complexity is a big of 1, because we are changing the old linked list. So can we do in some better way? So yes, we can do. Now how we will do this is starting with the approach 2. So what I'm saying, I'm just seeing I need a prime numbers. Okay. So what is the maximum value of node? Is a 10 to power 4. So can I create a sieve? Now what is the sieve? You know the prerequisite this problem is a sieve of Eratosthenes. Okay, something like this. I'm forgetting the spelling. Eratosthenes. Okay, so this is Eratosthenes. Sieve of Eratosthenes. So you know about this, and for solving this problem, this is a prerequisite. Or you can create any integer array. So you know if you are creating, or you can take instead of this, you can also check. This is a prerequisite. But if you don't know, we'll just learn this. I'll explain with the one more approach. So suppose I have any linked list like a 2, 6, and 10. Okay. So this is the linked list I have. So what I'm saying, can I generate the prime number to the 2 into 2, 10? Can I generate? Yes, I can generate. So what I'm saying, I'm just generate 2 into 10 into 20. So it will 10 2 to 20. I generate 2 to 20 prime number. So what is the 2 to 20? 2, 3, 5, 7, 11, 13, 17, and 19. Okay. So this is the prime number. So now what is the linked list? I have 2. So what I'll do, I'll find the upper bound. I will find the upper bound using the binary search. Okay. So if I found the upper bound, it will 2. What is the upper bound meaning? Upper bound meaning the element which is greater than the current number x. So you have to return the greater than number which is smaller among all of them. Greater than number. So you have to suppose number x. So you have to return a k which is greater than but smaller than all the number. Okay. So just greater than number you have to return. So for in this case, if you do the upper bound on x is equal to 2, what will be the output? Output will be the 3. Okay, so you'll just check the 3 and the previous number 2, and you will find the minimum distance, and you can apply the binary search on it because you are generating prime number in a sorted order. So let's see, but here the prerequisite is C of Eratosthenes. Try to learn this, and you can solve this time in a big of and log n. Okay, and using this it will won't change anything, it will go to the big of n root n, but I'll still tell you, because once you done the Sieve of Eratosthenes by yourself, you'll try to solve the problem very easy manner. So what I'm saying, I'll just create an one array. So before creating the array, I'll just find the minimum and maximum value. So the minimum value, I'll just take that int max, and what is the maximum value, which is 0. Okay, so initially I'll just check for the minimum and maximum value. Mini is equal to minimum of mini and current value. Okay, nice. And for the maxi is the same thing. So maxi is equal to maximum of maxi and current value. Okay, so it will give me the all the minimum values of minimum and maximum value. Okay, okay. Now I'll try to create a linked list. So what I'll do, I'll just again current is equal to head mark. Okay, now node star current is equal to head, will go from the head. Okay, nice. So what I'll do, I'll create one vector int all prime. So I'll just create all p. The value I don't know. So what I'll do, I'll try to go with the int I is equal to mini, and I go to the maxi, 2 into maxi. Okay, and I'll just generate. So on each time, if prime I, then the I is a prime number, what does all p dot push back? Okay, prime I. Okay, so you have the list similar to this. Okay, you have list similar to this. So what you will do, you'll apply the binary search on it. So what I'll do, I'll just copy this as well. Okay, so no need for this more function which is running big of k time. So you will reduce this k time complexity. Okay, so let's try to code it out. Now what I'll do, I'll just apply the binary search to get a values. So integer idx is equal to upper bound. Okay, upper bound on what, which value? It will take the idx. So I will do the prime. So I'll just do all p dot begin and all p dot end, all prime number, and what is the value? Value is current value. Okay, so you'll get a index of this. So I'll just do the all p dot begin. So using this formula, you will just get an index of the your next value. If idx is equal to 0, idx is equal to 0, then you don't have anything. So what you will do, you will just change with that value. Okay, what I have to say this, because if when idx come to the 0, so the minimum value is a prime itself. So suppose minimum value is a 2 here, so idx is a 2. Okay, suppose minimum value is a 1. Okay, minimum value is 1, but for what is the first prime number, which is a 2. So this minimum value, the next prime number is this. There is no previous prime number. Okay, because we are trying with the minimum value. Okay, or I can say, yeah, so there might be a mistake, I'm just going with this. So instead of making the minimum value, I'll just go with the 2. I just find a 1 cache, so that's why I'm not calculating minimum value, I'll go with the 2. So whenever I just the 2 will be output, either it will be the 2. So always if idx is equal to 0, then answer is always 2. Why I'm saying this? Because the minimum value is a 1. Okay, for the 2 the index will be the 1. Okay, for the 2 index will be the 1. Okay, so for the next values, else after that, here is the value is a 1. Okay, and the answer is a 2. So I'm assigning the 2 value here. So what I'll do, I'll just check with the if all p of idx minus 1 is less than all, or I just say less than and equal to all p of idx. So what I'll do, I'll just do the current value is equal to current value all p of idx minus 1. Okay, else current value is equal to all p of idx. Okay, and if I just in each point I'll just increase the current is equal to current next, and I'll try to return the head of the linked list. Okay, so let's try to compile it and try to submit it. If it is get accepted, we'll try to. Okay, so yeah, it passed the all the test cases. There is some issue. So what I have to do, current is equal to current value. I'm doing something wrong here. So here is max is equal to and current is equal to current next. So there is no current value. Okay. While I'm starting with the loop 2, because there might be a chances the minimum value. So or instead of this, the answer is a 257. Why? Yeah. So all idx is less than. It always less than, but I have to check with the x now. What about the x? You have to find the distance. So I'm not finding a distance. That's why the answer is wrong. So I'll do the distance as well. So x minus is okay. So as I am taking the abyss, there is no need to check the where x line first and second. It will give me the always absolute value. Okay. All p of idx minus x is less than. So x was not defined. Okay, my bad. So I'll define the integer x is equal to current dot value. Okay. So why I'm just changing the current again and again. So that's why I just do the x. Okay. Nice. So yeah, it passes all the test cases, and if I try to submit it, I hope it will get accepted. Yeah. So what is the time completion of this list? So it will go to the big of n into root n. Okay, big of n into root n, and so square root of n. And what is the time completion of this loop? It will go to the big of n into what is log n. Okay. Okay. So that's why the time complexity of dominating time complexity of big of n into square root of it. And if you finding this all prime numbers using the C of Herodotus, then it will be go to the big of n into log n. But we are taking extra space, so space complexity also the big of n. But this is the optimized approach and expected approach because it has a less time complexity. So instead of this, you have to just use the C of Herodotus. I'm telling the C of Herodotus is very important. If you want to video on it, just comment it out. I'll make video on it as well. So this is for today. Let's meet tomorrow. Bye.